Hi, I am Riku Arakawa from Carnegie Mellon University. Today, I am happy to present our work, CatAlyst, Domain-Extensible Intervention for Preventing Task Procrastination using Large Generative Models. This work was done with Hiromu Yakura from University of Tsukuba and Masataka Goto from National Institute of Advanced Industrial Science and Technology. While large generative models like ChatGPT show surprising performances, they are not always perfect to automate our intellectual tasks. For example, they are not capable of writing domain-specific documents or providing truly novel ideas that go beyond existing information available online. We considered whether it is possible to support workers doing various kinds of tasks using existing large models. We hypothesized that such models can be used for behavior change. More specifically, it will help us avoid task procrastination. In this context, conventional approaches are those employing site brokers with certain messages or visual feedback of task progress. We discovered the possibility of using large generative models to improve such interventions. Our underlying assumption is that even imperfect content generated by the models can be sufficiently used to guide users' interest to their intellectual tasks. I'll show you a demo of how our system, CatAlyst, supports a worker in slide editing task. A worker is making a slide about the climate change. The worker loses focus and starts watching YouTube. CatAlyst detects the distraction from the interaction log and notifies the worker with a generated continuation. The worker finds a new slide added to the last, which is generated by GPT-3 and Stable Diffusion. While imperfect, the slide inspires the worker and stimulates behavior for task resumption. The worker resumes the work easily, for example, by reformatting and modifying the generated contents. This is an overview approach of intervening with workers to enhance task engagement. CatAlyst first detects the moments where the progress of the worker's task is stopped from the interaction log. It then generates content that is likely to follow interrupted work using large generative models. For example, GPT-3 can be used in writing tasks to predict what would come next. Finally, it sends notifications to the workers while showing part of the generated content to induce them to resume tasks. This is an implementation of a CatAlyst prototype for slide editing task. Here, we use the GPT-3 model without fine-tuning to generate the continuation of the text to be on the next slide. In addition, we provided part of the model output to the diffusion model to generate an image that complements the generated slide. We want to highlight that in a similar manner, it is possible to introduce CatAlyst in new task domains by formulating appropriate inputs by prompt engineering, even if those tasks have not been considered at the time of model training. This is a benefit of CatAlyst, namely domain extensibility. Resuming an intellectual task while a worker gets distracted is expected to require cognitive load. In these situations, we expected that encouraging feedback, as in conventional methods, has room for improvement to provide more persuasive interventions, and that prompting workers along with a continuation would be more effective. By doing so, CatAlyst encourages workers to start thinking about the task regardless of the status, even for a short time, which is known as a popular practice to engage in the task. Here, James' clear behavior change strategy draws an analogy to chemistry's activation energy. He suggests using a catalyst, like intermediate steps with lower activation energy, to lower the activation energy required to start a habit. We expected that our strategy of using the continuation of interrupted work as an intervention would achieve a similar effect. To ensure workers don't ignore interventions, they need to be interested in them. Simple notifications can draw attention, but not always interest, leading to workers ignoring them. To avoid this, our strategy is to make workers interested in the content of the intervention by presenting the generated continuation of their interrupted work. Our goal is to prevent procrastination by encouraging workers to resume their task for 3 to 5 minutes. Fogg's behavior model states that motivation, ability, and prompts must align to achieve behavior change. Workers will be motivated to use CatAlyst-generated content if they perceive it as a collaborator. The continuation of the interrupted work can also improve ability, providing ideation support or reference information. We expect CatAlyst design to increase motivation and ability, guiding workers to quickly resume the original task.
The design strategy of CatAlyst, as discussed thus far, poses the following hypothesis. First, CatAlyst is an effective means to keep attracting the interest of workers who are away from the tasks by presenting a continuation of interrupted work as an intervention. Second, CatAlyst can induce workers' behavior to resume the original task effectively through the intervention. Third, CatAlyst can improve worker productivity by helping them avoid procrastination while performing tasks. And last, CatAlyst can lower the cognitive load imposed on workers while performing the tasks, thereby being favorably accepted by them. To test this, we conducted user studies in 2 task domains with according prototypes, writing and slide editing. We used various measures to quantify the efficacy of CatAlyst, such as ignorance rate of the notifications, interest retrieval time, progress the participants made after the task resumption, total time they spent on the assigned tasks, subjective quality evaluated by crowd workers against the product of the participants, and cognitive load and system usability examined by the participants' responses for questionnaire. While total time and subjective quality did not change significantly for the writing tasks, CatAlyst holistically exhibited its efficacy, supporting our hypothesis. At the same time, this result may be attributed to the fact that it might be the first time for the participants to interact with the recent large generative models. In other words, conducting a long-term study to deny the possibility that the effectiveness of CatAlyst depends on freshness is desirable. Therefore, we conducted a 5-day study with participants having diverse motivation and purposes for writing. We could not find a significant difference in the interest retrieval time across the 5 days, and participants continued the use of CatAlyst over the period. This suggested that the effectiveness of CatAlyst in guiding the participants' interest did not disappear even after long exposure to it. We also conducted semi-structured interviews and confirmed the qualitative benefits of CatAlyst. There are 4 main topics: effects on behavior, feelings about AI's accuracy, the role of CatAlyst, and room for further improvement. For the role of CatAlyst, different participants use CatAlyst differently, as a reminder, as an ideator, and as a peer. For details, please refer to the paper. Here, recent advances in large generative model have been remarkable. However, it is not guaranteed that they will work perfectly in all task domains, especially when aiming for higher levels of task delegation. While tuning generative models to improve accuracy is a theoretically valid solution, it is often impractical due to the tremendous cost involved, particularly given the variety of tasks and domains for which workers need support. CatAlyst demonstrated an alternative way. Our result exhibited that the ability of large generative models to produce context-aware interventions for supporting them. More importantly, the result demonstrated its applicability in multiple domains without fine-tuning, suggesting novel way of leveraging publicly available large models in a bricolage manner to support individual workers. We also acknowledge that it is possible to allow users to actively use large generative models, for example, by providing a button to generate continuation. However, we intended not to employ such a design because such an active use leads to users' higher expectation about the quality of outputs, which result in a higher risk of being distrusted when the quality is insufficient. In contrast, our design based on passive use leads to lower expectation and risks of distrust. This idea is common to unremarkable AI, which is introduced by Yang and others to explain the design of AI-based systems hiding the existence of AIs unless they are functional. We believe that this direction of AI-supported tool is promising to realize long-lasting human-AI collaboration. We want to keep exploring the effectiveness of CatAlyst in different task domains with a variety of attractive large generative models today. Thank you for listening.